XY plane. And our XY plane now is our what? In plane. Okay, it's our in plane. Okay, so I'm going to draw, I forgot to draw on the pink. So we know from here to here, so this is our shear YZ or shear max. YZ, and our last circle, the biggest one, over here. So now you realize something changed. Something's different now. Now we realize that our shear XY or shear max XY is equal to our shear max. Okay. So for this case, right? For this case, as you can see, that we have shear like before, like our shear max now changes. Sorry. So shear max changes to shear max XY, which is equal to shear max YX. So for this case, our shear max, the formula now changes, will be stress Y minus by stress X divided by 2. Okay, and now for this case, our maximum shear is now what? In plane. Okay, our maximum shear is in plane. So if we let stress Y to be equal to stress max and stress X is equal to stress mean, right? Your shear XY or shear max XY is equal to shear max normal stress max minus by normal stress mean divided by 2. So what is this unique thing now is your maximum stress now is your what? Is at the in plane. Okay, the one before, right? The one before, for this case, right? The shear max is what? Out of plane. For this case, right? The one that we have just constructed, the maximum stress is in plane. So what is interesting is this. If your structure happen to be loaded this way, right? It does not matter if you use 2D or 3D Mohr circle. If I were to draw 2D Mohr circle, this will still be my 2D Mohr circle. Yes or no? I don't have the other two circles, right? And your answer will be valid. You see where this is coming from, right? If your structure is loaded in the other way, where stress X is equal, greater than stress Y, then your analysis using 2D Mohr circle will not be what? Valid. You still have to use what? 3D Mohr circle. That's why I don't want it to be an engineer from McMaster. Our analysis is all by luck. Okay, I want you to be very, very sure. If that's the case, to be very, very sure, you all have to learn what? 3D Mohr circle. Not sometime, hey, the way my structure is loaded, I'm lucky. Okay, I use 2D Mohr circle, it seems to be valid. No. That's not how it works. Okay, we have to be very, very sure of our analysis. Okay, are we clear? So far, anyone, any question? I have another situation to bring you guys. Anyone, are you okay? Okay, right. So case number 3. I wonder, wait, hold on. Ah, yes. Okay, so case number 3. So same thing like what we have before. Okay, so condition number 3. And condition number 3 is throughout my analysis, I did not find cases where maybe one or two cases, okay, where I have stresses in 3D condition is when an object is submerged in water. Okay, so anything that's, and I don't do a lot of contracts or consulting that has submersion in water. A, I'm not specialty in that field. B, is not normal. Okay, it's not usual. So for condition number 3, okay, where stress X is less than stress Y, stress Y is less than stress Z. Now for this case, all are positive. Okay, all are positive. So we are going to construct Mohr circle again. So this is your normal stress. Okay, normal stress. And then we have our shearing stress. All right. Shear element clockwise, element go anti-clockwise. So this is your stress X line. So this is our stress X. Stress Y. And you can see from here what's going to happen already, right? And this is our stress Z. Okay. So this is our point X, point Y, and point Z. So same thing I'm going to construct again. From here, the XY is our in plane. Okay. So this is our XY plane. Okay, so this is our in plane. Okay, so if we look at tau max, so now our maximum is not in plane. Okay, so this will be your tau max XY. Okay, and then the next one, the other circle. So over here, this is your YZ plane, and this is your out of plane. And we will construct so again, this is not your maximum. This is not the biggest circle you see. So this will be your shear max. And this is your YZ plane, right? And then the last circle, which is the biggest one, as you can see, 3. Okay, so you construct more circle now. And this happens to the bigger circle. So for this circle, this belongs to your exact plane. Okay, exact plane. So, and this happened to your tau max. Oops, sorry. Now you can see now it has the biggest diameter. So this is your tau max, okay, which is equal to your tau max, and this is your xz plane. Okay, so if you look at the one before, right, the first condition is also in the exact plane. The third condition is also at the what? Exact plane. So we know that tau max is equal to tau max xz and this is also equal to your tau max zx, right? And the maximum shear now is occurring at what? Out of plane. So for this case, 2D, 3D Mohr circle, the answer not be the same. Okay, if you use 2D Mohr circle, if you construct using 2D Mohr circle, you cannot construct just using 2D Mohr circle. For this case, because you have stresses in what? 3 direction. In the other 2 cases, you can use 2D Mohr circle because stress Z is equal to what? 0. Okay, so for this case, you have to construct 3D Mohr circle. There's no 2D Mohr circle. I do apologize. So for this case, is your shear xz max or shear max xz is equal to maximum normal stress minus minimum normal stress and divided by 2. So for this case will be stress Z minus by stress X divided by 2. Okay, so this is different from condition number 1. Condition number 1, right, was stress. Wait, is this condition number 1? Yep. Condition number 1, where stress max is at stress X. Okay, and then the tau max is stress X divided by 2. That's it. Or stress max divided by 2, because your mean over here is equal to what? Is equal to 0. Okay, for the first case. For this case, is stress Z minus stress X. Okay, so 3D Mohr circle, we're going to have these 3 condition. Okay, we look at 3D. Okay, so what I'm going to do now, we're going to look at an example. Okay, we're going to look at an example. And we'll be solving 3D Mohr circle using Mohr circle theory. Okay, I don't want us to start using equations. Okay, and I'm going to show you why later on. Right. So let's look at example number 1. Before I do example number 1, anyone, any questions, please? Anyone? No? Okay. Let's look into example number 1. Okay. So example number 1 is slightly different from all the 3 conditions, because now this element is not on its principal plane. Okay, I'd like to highlight what do I mean by that. Okay. So we have a 3D Mohr circle. So for this case, the in plane, I'll declare that this is still my in plane. Okay. This is our in plane. Right. So if I were to draw a transformation now, X, Y, and then we have our Z. Okay. So we have a normal stress running at 120 megapascal. Okay. And then Y, we have a compression coming down, going down at 60 megapascal. And then stress Z, nothing. Okay. However, for this case, we have a shear. Right? Our shear is 30 megapascal. Okay. So this is very different from all the three conditions. Now we are given a shear. So this is not orientated at its principal plane because you have what? Shearing stress. Okay. So I'm going to label this X, Y,